Conversations about transparency and the government's relationship with data have played a pivotal role in public discourse in the United States in the last few years as the information age poses a whole slew of new problems. Now that I have the tools to store and process complicated data, I wanted to use this project to explore a landmark dataset within that conversation for myself, the State Department cables that were leaked by Wikileaks in 2011. Cables in this context mean internal communications sent between embassies or between embassies back to the State Department. So this is all information and internal communication related to U.S. diplomacy and U.S. engagement abroad. Now, initially, this data, which was given to WikiLeaks by whistleblowers, was released in a controlled and piecemeal fashion to journalists, but then through a combination of events including a volunteer uploading an encrypted file as an insurance policy, and then an erstwhile writer publishing what he thought was just a temporary passphrase to that file, the entire repository was made public in 2011. That included 251,286 files, and while these do span as early as 1966, the vast majority fall between 2000 and 2010. The breakdown is about 15,000 secret, 102,000 confidential, and 134,000 unclassified. All this data was released in SQL form, and the columns included date, so chronological information, categorical information, geographical information encoded in origin, destination, and header, but which needed to be extracted, and then the actual content of the cable itself. All this data was aggregated and geocoded in Python. Regular expressions were used to extract the city names from those strings and then canonicalize them. Those canonicalized names were then fed to a geocoder library, which used Google on the back end, and produced matches for 94% of the cables. It was then joined on country code to aggregate by country, typo there, and by region. The final step was to use LDA modeling, which is a generative text modeling approach, on the cable content itself to represent cables as distributions over a finite topic set as opposed to a huge vocabulary of words. Now to look at the visualizations themselves. Excuse me for a moment here. The first visualization was designed to show flow of cables over time. So the idea here is to look at the asymmetry of flow and also look at which areas have the highest volume and then how that changes over time. Initially, I wanted to put this in a geographic context, but then I realized that this might, be distracting, and that it was trying to show flow to all of these different cities all over the globe, and also that the geographic background might distract from the actual flow network that I wanted to show. And so I decided to, instead of the prototype that you see here in the sketch, use an approach called a chord diagram, which you can see here. Now, obviously, this is a pretty primitive version. It's aggregated by region. I think I'm going to have to actually re-aggregate it to make it a little more balanced and a little more interesting. Oceania doesn't contribute all that much to the conversation, sadly. And also make this able to shift over time to see how this distribution changes over time. But this is the approach I will be following. Now, the second visualization is fairly straightforward when it comes to actual techniques. This is 2 bar graphs that are going to be linked. And the idea here is to show the breakdown between secret, unclassified, and classified, and then within each year and within each status to show the geographic breakdown. And just take a look at the prototype I have of that. This will eventually be interactive as it is now. It'll eventually be interactive and allow users to click on a single year and to then see the horizontal bars on the right-hand side become updated and filtered for just that year. Now, the 2 other visualizations, which I haven't prototyped yet, are these, which are linked. The first is a choropleth, and this is going to be fairly straightforward. It's going to show either the density of cables received or of sent, depending on user choice, for a given time period, probably a given year within 2000 to 2010. And then when a user clicks on a country, this tree map here will update. And what this tree map is going to be showing is the breakdown of topics that are most common within that country. And because of the nature of the way topic models are returned, which is that a set of words which can be interpreted as one overarching topic, these things can be grouped into ideas like, is it to do with conflict? Is it to do with economic issues? And so the tree map structure can be utilized to show the breakdown of topics within these larger categories for the country that these are selected in the choropleth here. So I'm very excited to be working on this project, and I'm excited to have gotten the chance to share it with you. Thanks.